Welcome to a new lecture from our physics course. Today we will talk about a new chapter, the oscillatory motion and the mechanical wave. Oscillatory motion is any repetitive motion for an object that he can move in a circular motion or in a linear motion, and that object is able to go back to the same place where he started at the same exact position. So oscillation, as simple definition, is a repetitive back and forth or rotational motion. One complete oscillation is called a cycle. You can see the bee over here. If you focus on the wings of the bee is oscillating her wings up and down with a certain angle, getting far from each other and back together, back and forth, to be able to push the air around it and be able to push herself and fly. The motion of the bee wings is called an oscillatory motion. While we're talking about oscillation and oscillatory motion, it is important to know the cycle. As we mentioned, it's one complete oscillation, that's called the cycle. We talked a little bit previously about period and frequency. We still care about those terms and definitions as we are talking about mechanical wave and oscillatory motion. We discussed as well before about the period. The definition of the period is the time required for the wings to make one complete oscillation. If the period of each cycle remains constant, then that means the wing is moving up and down with an oscillatory motion. And we remember before that the number of oscillations per second is the definition of frequency, that we can measure it by hertz. And the equation for frequency, we remind you here, equals 1 over t, which means frequency equals 1 over period. It is important to notice that the car in your parking lot is having an engine that is heavily depending on oscillatory motion. So the pistons inside the engine are doing oscillatory motion all the time, and that's the basic concept of how internal combustion engines work. So this piston is within an engine cylinder. That's the silver box you see around the engine. So as those pistons are going in linear motion up and down, it is squeezing the gas and the oxygen and waiting for the spark to happen. When the spark happens, the gas and oxygen will explode. That explosion will push the cylinder back. Each cylinder of these is connected into what we call it a crankshaft. This crankshaft will be rotated. Those cylinders are being engineered and designed to fire or explode at a certain sequence so that the rotation is not interrupted, and all the pistons are contributing positively to the rotation of the crank and eventually to the rotation of the output shaft that will deliver the power to the powertrain and eventually to the wheels. So those pistons move from the highest point to the lowest point, and it begin moving up and down over and over again. And single piston in one race car can achieve a frequency of 300 cycles per second or 300 hertz. So the piston make 300 complete cycles in only 1 second, which is crazy and impressive. So that roaring sound that you hear from the engine is the sequence of the motion of those cylinders and the sequence of explosion between those cylinders to be able to spin this crankshaft and deliver the output force to the powertrain and to the wheels. So if you want to know what is the period of that piston that have 300 complete cycles in 1 second, so the time for one complete cycle is the inverse of frequency. So it is 0.003 or 100 times faster than a blink of an eye. Let's take a quick little simple example. What is the frequency of a car engine in which the piston oscillate with a period of 0.0625? So we have the t as 0.0625 seconds. Frequency equals 1 over t. So we can say 1 over 0.0625 equals 16 Hertz. So the frequency of the engine in this case is 16 Hertz.